right, hey everybody. My name is Brandon Kortz. I'm the head of Startup Pipeline at Newlab. So if you have portfolio companies that can benefit from the system that we've been talking about all day, I'm the guy to talk to, and I really want to connect with you. More startups are more valuable for us. I'm really excited to talk about Vycarb today. They're a company that came to us through our partnership with the Activate Fellowship. So Activate NYC, all of their companies have full access to Newlab for the duration of their fellowship. And that includes lab access and desks for the founders. And so Vycarb came to us through that program and really has leaned in to this system that we've built, and specifically the infrastructure here in Brooklyn. They've increased the number of desks that they've had. They have build space here. They're a really significant piece of the ecosystem, and I think most importantly, today we're focused on piloting. They've been working with us and our wonderful membership team to work with Yard Labs, the Brooklyn Navy Yard's piloting program, to actually get their technology, its carbon capture MRV technology, into the East River on the Brooklyn Navy Yard. So I'm very excited for you to learn a little bit more about that from Greg Humphries, head of business operations at Vycarb.
Good afternoon, everybody. My name is Greg Humphries. I'm the head of business operations at Vycarb. We're a startup enabling what we call fully measured carbon removal in water. And fully measured really is the operative part of that sentence. To give you a bit of context for what we do, the ocean's massive. Historically, it's been a carbon sink and has absorbed about a third of human CO2 emissions. But the issue is, as we continue to emit more and more CO2 over time, the ocean's also becoming a carbon source in certain parts. In other words, the ocean in total is now responsible for about 10 billion tons of emissions via a number of high CO2 waters. And our goal is to prevent those emissions, biogenic CO2 emissions we'd refer to them as, by removing CO2 in water permanently. Now, the founding story for this is that CO2 is very hard to measure once it enters water. It's very easy to measure in the air. We can use spectroscopy, but as soon as carbon goes into water, it takes many different forms, and water's natural carbon cycle means that it's very hard to quantify. Fortunately, we said this is a tech problem, and tech can solve this problem. I should note, I did not solve the problem. I'm the business person here, but some of the very smart scientists on our team did. So Garrett, our CEO's founding story for the company was that via the Activate Fellowship and following on from research trials he'd been doing at Cornell, went out to develop this system for direct, autonomous, and real-time measurement of CO2 in water and integrate that system into the removal process too. So the tech accomplishes permanent and safe carbon removal in water, and it really is powered by that direct, autonomous, real-time measurement from start to finish to ensure that every gram of CO2 we have removed and will ever remove is fully measured. Our major achievements to date include demonstrating this first at a very small kind of lab scale here at Newlab, and then out at a prototype system on Governor's Island in New York. We secured our carbon removal pre-purchases, the first via Stripe Climate in 2023, and then the second very recently, last week, through Milky Wire. And we secured our first commercial deployment customer, which is hopefully going to be deployed in 2024. And that is a full paying customer who's utilizing our technology for fully measured carbon removal in water. Now, the pilot opportunity, as you can see here, is literally in our backyard. It's about 200 yards that way. It's a 15-minute walk, snaking through the Brooklyn Navy Yard, but it is right outside. And this really does leverage a lot of the benefits which Newlab and the Brooklyn Navy Yard provide, and just how powerful that's been for us as a company. And to run you briefly through how the tech works, we have this on-land component which includes our measurement system, the proprietary sense technology we have, and mixing systems. And then we also have a submerged reactor in which we add a precise dose of mineral alkalinity, which is what powers that carbon removal reaction. Scoping the pilot obviously has been a long process for the company, and as I said, started in a lab and then followed on to a prototype system which we had at Governor's Island in New York, which is what you can see us working on here. So just over the water on Governor's Island was where we first deployed this technology in a real world setting. And that was a batch flow system, which allowed us to do about 1 kilogram of carbon removal, fully measured per year. Now, obviously, 1 kilogram of carbon removal is unfortunately not going to halt climate change. The good news is that is not the end goal for us. So the pilot we're deploying at the moment is going to be able to remove about 100 tons per year of CO2 from the water. And what we're looking to eventually is going to allow us to remove 100,000 plus tons and eventually 1 million tons plus per system of CO2 from the water. As I said, this pilot leverages a lot of the really important parts and benefits of what Newlab provides to us as a company. As Brennan noted, we arrived at Newlab because of the Activate Fellowship, and now we are not leaving Newlab, and we have been here for a very long time, and we are making sure to get every last drop out of those benefits which Newlab provides. That for us is obviously the space right next to the water. That for us is the industrial area in which we're in and how important that is to deploy industrial scale technology. And it's also the lab space which Newlab provides, the build space which Newlab provides, and the incredibly inspiring and talented community here of builders, engineers, and scientists who we've been drawing on for the past 2 years as we've been here. This specific partnership is run not only with Newlab, but with Brooklyn Navy Yard's Yard Labs, which is a program essentially helping pilots deploy in the Brooklyn Navy Yard to get tech out quickly and effectively. And as I said, this is not the end goal for us. Those 100-ton per year shipping containers which you see are effectively modular and repeatable systems that we can deploy not just to the Brooklyn Navy Yard, but at distributed locations around the world. This speaks to our business model as well at Vycarb, that we're not only looking to be the project developers here, but we want to be the technology developers. We want to build systems which measure, remove, and store CO2 and water, and put these in the hands of companies, municipalities, organizations who have the existing assets to deploy this cost effectively. And so this you can see here, unfortunately, is a render. We wish it was real. But it's a system that will be capable of removing about 10,000 tons of CO2 per year in natural waters.
The biggest problem with carbon dioxide removal is we don't really know how effective it is. At Vycarb, we're really shifting that paradigm. We're saying that actually the measurement has to be part of the removal. What we've done with our low-cost autonomous technology is enable that really high-quality measurement with really low cost. This is the first technology that couples at every step of the process carbon removal and measurement. And the way we do that is by measuring how much CO2 is in that water, and then based on how much CO2 is there, adding a precise amount of alkalinity, different materials that convert that CO2 into dissolved, stable, inorganic carbon, like bicarbonate. Watching that CO2 go down, we can really provide full confidence in how much carbon is being removed.
So the final thing which I'll maybe mention for probably the dozenth time here so far is that the really core word of our value proposition is autonomy, autonomous measurement, autonomous deployment, autonomous removal. The fact that we can use that integrated measurement system, which gives us full control and transparency on how much CO2 is in the water, to really control the dosing of that alkalinity, is what enables us to put this tech in other people's hands. Now, the outcomes from this pilot, obviously 100 tons is what we're targeting right now from May to May next year. That also means 70 billions of liters of water treated annually. Deer certified water, improved water quality, better for fish, shellfish, and other marine life. And it means we're getting to a price of below $500 per ton of CO2 removal. And we want to keep bringing that number down to make carbon dioxide removal more accessible for people around the world. But this puts us on a really strong and clear path there. And finally, and perhaps most importantly, this pilot's allowing us to demonstrate the commercial viability of our technology, meaning that we hope we complete this Stripe pre-purchase by 2025, and that as we move into 2025, we're moving on to commercial deployments. So full paying customers using these pre-purchases, which we've already secured, to enable safe, cost-effective, and scalable carbon dioxide removal around the world. Thank you very much.